Good morning. So we are going to talk about AI, of course. And I'm going to tell you that AI doesn't exist. So it's going to be a difficult talk. Anyway, so we can switch to the slide. I'm the guy with the Hawaiian shirt. I'm the only one in this room again, but one day you will wear one. Anyway, so yes, there is no such thing as AI. I mean, actually, you know, when I say that there is no such thing as AI, the AI that people are talking about in the media. You know, the AI that is the Hollywood AI. I mean, AI is not science fiction. AI is science. So what I'm going to tell you today, through the history, a little bit of the history of AI, we are going to calm down a little bit and to realize what it is and what it's not. So artificial intelligence actually started in terms of naming about 67 years ago. So it was in 1956 that some scientists, you know, back in the States decided to call this field artificial intelligence. And I have an issue with that because actually there was nothing, you know, about intelligence. It was all about artificial. So we shouldn't have called that like that. And I think this is why, you know, now we are making a lot of assumptions about AI can do what AI can do. You know, I think that it's a big, big mistake, but I'll come back to that. But anyway, at the time, what they tried to do, they tried to model basically the brain through what we call now, you know, neural networks. And again, it was very, very simple. And the bottom line is that at the time, they failed. They failed to do what they promised they would do, to create those machines that are going to be intelligent machines that are going to think and to do things, you know, that are intelligent. So they failed, and we entered the very first winter of AI. You know, winter of AI is what? Is when there is no more funding because we were lied, you know, about this technology. So we need to be careful, you know, that it doesn't happen again. So we need to be very, very straight about what it is and what it is not. But you know, think about what they were trying to do, you know, 67 years ago. I mean, they were trying to do this, you know, kind of machine that is going to look intelligent. But actually, this is what we are doing for centuries. And as you can tell from my accent, you know, I'm French. And there is this French mathematician and philosopher back, you know, in 1642, who created the Pascaline. The Pascaline was the very first calculator, basically. And it was a long time ago. And it was an intelligent machine. I mean, it was doing, you know, A plus B. It was doing addition, subtractions. So it was pretty intelligent, right? It was very narrow in terms of what it was doing, but it was doing the stuff pretty well. Actually, it was doing the stuff very much better than we do, right? And this is the story of those AIs. The AIs are tools that are doing very specific tasks that are just doing the tasks better than us. This is the definition of a tool, right? It's doing the stuff, whatever it is, better than us. But it's not doing all the things that we can do, okay? So the machine at the time, the Pascaline, you know, was doing some very complex addition and subtraction. You are going to tell me, yeah, it's not that difficult, you know, addition and subtraction, but if I ask you, how much is 1752 plus 925? Okay, so the machine would have done that in 3 seconds, right? You cannot even give me the result. So, I mean, again, we are building those machines for a long, long time that are doing some very narrow, specific stuff, much better than we do. And this is what artificial intelligence is. It's about doing some very narrow stuff, very much better than what we do. It's a tool. It's a bunch of tools. If I have to give the definition of one artificial intelligence, I would say that it's one toolbox. A toolbox with a bunch of tools that are very, very different inside the toolbox. Like the screwdriver is different from the saw. Like the saw is different from, you know, the hammer, right? So a bunch of tools, very different, very specific for a specific task. And those tools, they are very powerful because they do the task very well, much better than we do, but they can also be used to do the task very badly. They can be used to do something else. All the tools can do that. The hammer can be used to, drive the nail in the wall. The hammer can be used to hit, you on the head. This is not meant for that. This is why we need regulation. We need to regulate. We need to understand how those tools are working and to regulate them in order to use them correctly. You need to learn them first. We need to understand what they are and what they are not. And once we understand that, then we can use them, the right way. Because they are powerful, they are very good, but they can be also very bad. So anyway, 1642, 1956, they were trying to do something very difficult, actually. They were trying to do natural language, to fix natural language or to solve natural language. It's a very difficult thing to do. That's why they failed, right? Even today, even with generative AI that we'll talk more about later, natural language is still a very, very difficult topic. They failed, and it was the winter of AI. Another AI came by, at the very same time, actually. It was the expert system, the logical AI, okay? So the very first AI was statistical, the next one was logical, and logical AI worked pretty well. In the 60s, 70s, 80s, 90s, we had a lot of expert systems. And one of the best ones was the one that beat Kasparov at chess, right? Deep Blue by IBM. It was a very impressive system, but it was just a set of rules, right? And chess is a game with rules, and Kasparov, world champion, was beaten by the machine. We can always create some machines that are going to be better than us at specific tasks, okay? Then came the statistical AI came back, and it was in the 90s, and we called that machine learning, and it came back because something happened. The internet happened, and the internet came, with a lot of data, and later it was even more data, and we call that now deep learning, and actually today it's even more data, and we call that generative AI, a lot of data. Too much data, actually, In 1997, when one of the first recognizers was created, in machine learning, it was a recognizer of cats, You're going to tell me why? Because there were a lot of cats on the internet. And it was the biggest database of cats, because people were posting images of cats, and it was an annotated database of cats, because they were saying, this is my kitty, this is my little cat, blah, blah, blah. So a lot of cats. What was a lot of cats at the time? Hundreds of thousands of cats, right? And with about 100,000 of cats, we were able to create a recognizer of cats that was recognizing cats at 98%. Wow, that's an intelligent tool, right? Very impressive. Actually, it's not impressive at all. How many cats do we need, us humans? How many cats my daughter, my 2-year-old daughter needs to recognize cats at 100%? 2. So we are building machines that are using 100,000 of cats to recognize cats, when my daughter can recognize cats with 2 cats. Those machines, they are not using at all the same techniques that we are using. This intelligence has nothing to do with our intelligence. It's powerful, maybe too powerful, in the sense that it's taking too much power, too much data, too much power. And here, I was in 1997 when we were using this kind of power. But today, with Gen AI, this is billions of data. Billions of data. We are basically eating the planet with those AIs. We need to be very careful. We need to choose how and why we are using them. So, one thing that happened, a little bit later is, about 10 years later, was the world champion of Go, that guys, that was, beaten by the machine. This time it was, DeepMind instead of Deep Blue. It was very impressive. It wasn't using the same logical techniques that it was using in 97. It was using now, deep learning. Very impressive, the guy was beaten. Go is much more difficult than chess, right? Chess is only 10 of the power of 49 moves. Go, we don't know, right? It's a lot. It's infinite. It's not infinite because it's a finite game, but it's a complex game. So we had to use deep learning to create this machine. And this machine works, very impressive. But it uses a lot of data. It uses a lot of power. Way too much power. This machine, DeepMind, was actually using about 1,500 CPUs. 1,500 CPUs just to play Go. 300 GPUs. 300 GPUs. And about, 30 TPUs. TPUs were new at the time. It was this new TensorFlow kind of processing unit. So a lot of processing power just to play Go. I mean, we have to compare now those, 2,000 machines. That is a small data center, basically, that are going to compete against the human. And this little Korean guy, who was the world champion, what did he have? Just that. So we had something like, hundreds of CPUs against this guy that had only that. And that is what? That is 20 watts. We had something that was 440 kilowatts against 20 watts. Of course it won. But it doesn't matter. It's ridiculous to use this kind of power, especially for a game. We need to be careful because we don't have, that much energy in the world. We know that more and more, so we need to be very careful. One thing that I want to say also about the data is that the data is actually bad. The data is always biased. Every time you use, data that are a lot, you cannot verify them. You cannot verify that they are all good. And you know what? They are bad. When we talk about Gen AI today, Gen AI, it's about, basically all the internet that is used, to create those models. It's a lot. It's billions of data, right? And I guess that on the internet, you don't have everything that is true, right? There are some things that are wrong on the internet. We agree, right? So the issue is that when you create a model that is going to use the internet, you are creating a model that is interestingly wrong, okay? So you are going to have some bias. You are going to have some things that are wrong in the model itself. And by the way, ChatGPT, the 3.5, we never say anything about the accuracy of the model. We just say, yeah, it's great, it's doing everything, blah, blah, blah. But what is the accuracy? Do you know? Did you hear about it? I mean, there is a study from the University of Hong Kong that was released in February, so 4 months after ChatGPT was actually released, and we needed the time actually to do the study because we need to do the study on a lot of data. And in this case, the University of Hong Kong, they did the study on millions of facts, of true facts, whatever that means, right? And so they fed the machine with the true facts, and they asked ChatGPT if it was wrong or right. But it was all right. But ChatGPT sometimes found it was wrong, okay? So bottom line, the ChatGPT accuracy, 3.5, the ChatGPT accuracy of 3.5 was 68%. 68%. So you can say that it's great, or you can say that for an expert, it's pretty bad. I say it's pretty bad, right? I cannot rely on this thing. So we need to be careful. It's not because, the media and other people are saying, yeah, it's great, just use ChatGPT for everything, that you should use it. You should learn how to use it. You should use it, but know that it can, spit some crap. We need to realize that. And sometimes we don't. So one of the examples, of those data that are wrong is what happened, back in 2016 as well. It was Microsoft TIE. You might remember it was, another chatbot, but it was back in 2016. And TIE was basically a chatbot that was meant to, answer about some Microsoft products on Twitter. It was Twitter, it wasn't X. So anyway, so TIE was, released, and Microsoft had to unplug it after 16 hours of operation. Because TIE became the most racist and sexist, chatbot in the world. It basically, said a lot of bad things about black people and women. So, why? Doesn't make any sense. Of course, Microsoft didn't want this bad publicity, right? But the reason was because the database on which it was trained was racist. Because they used some data from the 50s and from the south states of the USA. And those states, at the time in the 50s, they were racist, right? So the database was racist, and it didn't take a long time for basically the robot to become racist and to be bad and to be unplugged, okay? So we need to avoid these kind of things, but it's very, very complicated because the more data you have, the less you can control it. But if you realize it, you can explain what are the behaviors that are going to happen, right? But we need to be very careful. Another thing that I want to point out is that we talk a lot about the fact that AI is a black box, right? AI is a black box, we don't understand anything, and so maybe sometimes we say that's why we cannot trust it, right? Actually, it's a very difficult thing, because I don't think it's a black box. I think that somebody, somewhere, can explain what is happening. The people who are creating those AIs, they chose the data, can be wrong. They chose the algorithms, can be wrong. But they know, they have a feeling of where it's going to tend towards, right? So this is something that is not a black box in the sense that the creators of those AIs, they pretty much know where it's going. Actually, every time there's a new science somewhere, every time there is something new, we talk, about the fact that it's a black box, that we need to be careful. But those sciences, the more we learn about them, the more they become transparent. And the more, we can understand what they are doing, even though we don't understand all the details. I mean, I don't understand all the details of the mathematics, and some of the differences. But, I mean, I know a little bit more than what I knew, when I was a kid. So things become more and more transparent. So we cannot say that it's a black box. We can say that we don't understand it. We can say that we could learn more about it, but we shouldn't call that a black box. One thing that I need to talk about, because I'm at Renault today, Renault, as you know, because in Korea, of course, Renault is well known as the former Samsung brand. I'm going to talk about the autonomous driving. Of course, I'm going to talk about those autonomous cars. And like artificial intelligence, actually, I'm going to tell you that autonomous driving doesn't exist and will never exist. Might be a blow to you. You might say, too bad, I wanted to have my car driving by itself. It will never happen. I mean, let me rephrase it a little bit. So, autonomous driving level 5 will never happen. Autonomous driving level 5 is the one that Elon Musk is talking about for about 10 years now, okay? So this one will never happen. I'm going to prove it. Don't worry, I'm not going just to tell you. I'm going to prove it later, but autonomous driving level 5 is basically, having a car going from a point A to a point B in any circumstances, and it's going to succeed without killing anybody, right? Pretty nice. This is what will never happen. There will be accidents. There will be issues. And there will be issues sometimes, that cannot be resolved by AI or by those autonomous driving cars. Okay? Again, I'm going to prove it, but if there is level 5, it means that there is level 4. Level 4 will happen. Level 4 is going to, be mostly autonomous, but sometimes it will need some human intervention. This is going to happen. But to give you an idea of where we are today, I mean, today Tesla is at level 2. Okay? So way far from level 4, level 5. And there are some companies in Europe, in Germany, that are saying that they are at level 3 today. Level 3 is basically, you can have those cars being autonomous on very specific conditions, on freeways, not very high speed, blah, blah, blah. Okay? So there is already a lot of what we call ADAS that are helping the drivers to be better and to be more secure. So again, it will progress, and I think it will progress towards level 4. But let me go back to level 5 and explain why it will never exist. And for that, I'm going to take the example of what the CEO of Waymo is the Google side of the autonomous driving, basically. The CEO at the time in 2018, because Elon Musk was repeating, all the time that autonomous driving was for tomorrow, he said, okay, we need to stop the bullshit, and for that, I'm going to give to the community all my data. And those guys, they had a lot of data. And what was the data? It was videos of miles that were driven, all over the planet, right? So they had a lot of miles. Actually, it was 10 million miles of videos that he gave away, basically. And he put that on YouTube. I mean, this is Google after all, right? And of course, people like myself, as soon as, it was posted, we went to look for what I'm going to call a gem. What is a gem in this case? A gem is something that is going to prove that I'm right, okay? And so I didn't have the time to look at the 10 million miles, of course, right? It's long, but I didn't need it. And now I found actually a bunch of gems, a lot of gems. I'm going to show you one today, but there are plenty of them that are showing that it's just impossible. What is the one that I want to talk about today? It's a car that is driving in the streets of Mountain View. Mountain View is where the Google HQ is. And so this car is driving in the street of Mountain View, and it's pretty boring. Nothing happens in Mountain View. And so the car, in the middle of the street like that, stops. And then, after 2 or 3 seconds, starts again, and stops after 2 or 3 meters. Starts again, and stops. Starts again and stops. And it does that about 3, 4, 5 times before we see the safety driver, we see the hands of the safety driver, coming on the wheel, and then, drive away, because behind him, people were wondering, why this guy was stopping every 3 meters. Didn't make any sense. There was nobody on the road. There was nothing on the road. Didn't make any sense. Unless you start to look at the video a little bit closely, and you see that on the sidewalk, 2 guys are walking in the same direction of the car. Good. But you see that one of the 2 guys, the one that is the closest to the street, is walking on the sidewalk with on his shoulder a stop sign. So you see, you humans, you see a guy on the sidewalk walking with a stop sign, you don't stop. If you do, you need to come to see me. I have to talk to you. Okay? So you don't stop, but what does the robot do? What does the autonomous driving car do? The car sees a stop sign, and a stop sign, and a stop sign. The car cannot adapt to something that it never saw before. We do adapt. We do invent. We do create. Artificial intelligence doesn't. Artificial intelligence doesn't create. And this is something that is very important. And actually, I was saying earlier that generative AI, has some good points. Its name is a good point. We didn't call that creative AI because it doesn't create. The creativity of generative AI is still on our lap, it's still on our side. It's not creative AI, it's generative AI. It generates whatever we want it to generate. We can, influence in the prompts the answers. And when you look at generative AI that is actually creating drawings, it's even more obvious. I mean, if I type something in the prompt like, draw a pink cow on top of the Eiffel Tower, right? It's going to generate a bunch of images of pink cows on top of the Eiffel Towers. It's great. This is what I asked. But I did create the pink cow on the Eiffel Tower. Creativity is on our side. Those tools, they are incredible. Those tools are very, very good. Those tools help us to create, but they generate what we want to generate, to create. Okay, so I'm going to pass on Siri because, it's now an old thing, and I'm sure that with you, and if we want to, we can talk about it. But it's an old thing. There was a lot of natural language. Natural language now with those Gen AI is also being challenged, so it's very interesting. But you all know Siri, so there is no point to talk about it. But what I want to finish with is basically to say that AI, I call that actually augmented intelligence. I mean, it's actually just to keep the A and the I. But the augmented intelligence means that it's not actually the domain. It's us being augmented by those intelligences, by those tools. We are being augmented because those tools are actually helping us to be more intelligent, to be better on whatever we are doing. Okay, very quick now, I'm going to give you something that you will remember all your life. You ready? Yeah, you're ready. Good. I'm going to define intelligence. I didn't define intelligence yet because I don't know what it is. And actually, nobody knows what it is, right? But I'm going to define it mathematically. I'm going to give you an equation of intelligence. Really simple. I'm going to project all the definitions of intelligence. I'm projecting it on this graph, right? So I'm going to say, okay, intelligence is going to be, something between 0 and 100. So 0, Donald Trump, and 100, and 100, a genius, right? So I'm going to project all the intelligences there. This is us humans. We are not that smart, but we are pretty smart, and on any domain, because here this is all the domains that you can imagine, right? All the domains are there. Okay, anything, we can say something about that, especially us French. But anyway, so it's another thing. So this is, I would say, a continuous line, okay? Continuous line across all the subjects, right? And now I'm going to say, actually it's infinite, because we invent stuff, we create stuff. Infinite, great. Now let's look at artificial intelligences. Where are they? Chess. It's a genius, right? Beats us all the time, that's fine. Go, it's even more than a genius, impressive. Driving, it's pretty good. Level 4, will happen, level 5 won't, but, better than my son. Anything, I'm talking about delivery, we don't care. Anything, I can create a tool that is going to be better than me. This is the definition of the tool, right? But what is it here that I have? In mathematics, this is not called continuous, This is every single thing is, the intelligence is in its own little domain, right? To create something that is continuous with those sparse lines, I need infinity. I need an infinity of artificial intelligences to match my brain. So you might know that infinity is complicated. You know that, right? It's a lot. So anyway, it means just that we cannot match that. And if I look at two domains that are very, very close, here I have delivery and driving, for instance. If I look between the two of them, between those two connects lines, actually there is something else that is called also infinite, right? So I cannot do the transfer learning that we are hoping to do, because there is always a case that is not going to transfer well from one domain to the other, right? So transfer learning is a good idea, but cannot cover everything. And everything that is going to be created by myself right now, everything that is going to be my creativity, there is no artificial intelligence yet. We are at 0. Thank you very much.